Okay. Well, I think I will also record this meeting. No, I think it's better to record the meeting also, if you don't mind, for us to have the report. Well, we are going to start, and to avoid delays. Well, I would like, first of all, I would like to thank all of you for participating in this webinar today. It would be fantastic to have had the meeting we planned in person, but life has changed a lot this year, and we are learning how to work in a different way. I am also. We are going to have only 2 hours during these 2 days to show some of what was already been done, some of the preliminary results, and we hope to discuss these results, methodology, and guidelines in these 2 days. They are organized in a way that we are going to have presentations more related to greenhouse gas network in this first day, and tomorrow we see the pollutants, gas, and particulate species. During many years in the past, our contribution to the São Paulo atmosphere composition has been concentrated on the regulated pollutants, on the measurement of regulated pollutants. Then we started these measurements of greenhouse gases only very recently, and then we have a lot to learn and to share with you. Although this year we had a lot of constraints, mainly related to do the experimental work, we keep trying to follow the agenda we proposed. And it has been, I must say that it has been a pleasure to work with so involved and dedicated colleagues, and the young generation who was incorporated to the METROCLIMA staff and is going to present many results today and tomorrow. I'm sure that this presentation will give a good overview of the project development until now. I would like also to ask you to keep the microphone muted during the presentations. And the questions can be done by chat. And it's nice because you can ask questions in Portuguese or English, and then we can answer. It's better for I think, even for people to make questions, to feel more free to make any questions that they want. I prepared only a small presentation here, only to, I will share my screen. Okay, let me share the screen here. Only to start. Can you see my screen?
Yes, we can.
Yes.
Thank you. Well, this project okay.
Yeah, it's the same to me.
Okay, I will. You say stop completely or stop sharing the screen? Maybe maybe it's better to share only the screen, no, only the PowerPoint.
Yes, I think that was the problem.
Yeah. It's not appearing here. I don't know why. And now, can you see? No. Okay, sorry.
Yeah, that's fine.
Okay. The São Paulo, the project is São Paulo metropolitan area, jointly tracking climate change and air pollution. We include air pollution, the regulated pollutants in the project also. And the motivation was that we had this conference of the parties agreement that was signed in 2015, calls for the strengthening scientific knowledge on climate, including research, systematic observation of the climate system, and early warning systems, in a manner that informs climate service and support decision making. And the other motivation for this project is that the São Paulo city is a mega city, and we have emissions by our emissions is by traffic, it's coming from traffic, and it is São Paulo. It's like a lab that we have all these emissions, and it's the biggest mega city in the southern hemisphere. Then we put two goals. That's the main goals. That are here. The overall objective of the project is to examine the role of São Paulo megacity emissions as drivers for regional air quality degradation, for GHG and short-lived climate pollutants and climate change. And the project aims to integrate multi-platform measurements and modeling tools to describe the atmospheric behavior of these pollutants and the effects of climate change on the air quality in the metropolitan area of São Paulo. We organized some tasks, and we are trying to develop these tasks at the same time. Then we have this implementation of the network with surface measurements, fluxes, and integrated atmospheric vertical columns. At the same time, the development of emissions inventory from multiple sources, sectors, trying to have the spatial and temporal resolution. Development of this atmospheric transport model description of CO2 and methane. And then at the end, to assess the impact of climate change feedback on air quality in the metropolitan area of São Paulo, that we have some colleagues working in this topic also. Then we have this, we can more or less put all that we are doing in these tasks. The organization is, with this box, we can, sorry, I was trying to put the pointer. We have here in blue, it's the part of the emission. In red, here the modeling that we are considering till now. We are having the observations, the surface observations and the satellite observations and the FTR and LiDAR. All these we hope to integrate in the modeling, and then we at the end we can have the verification. This kind of organization can make easier to us to know what we are doing in each step and how we can put all the steps, all the boxes at the end together. Concerning the experimental activities, we have at the same time these measurements with particles and the measurements for the gas phase. We have more experience already with regulated pollutants, because we have this project for many years, and also the measurements of particles. Here, Eduardo also is going to speak about the LiDAR systems, and tomorrow we are going to have some presentation about the particles. Only to make a quick overview of the history of the project implementation. It was a long history. In August 24, you see, many years ago, I don't know if people remember, but we had a visit from people from JPL, Arizona and East, some colleagues that are now present here, participating in this meeting, like as Charles Miller and other colleagues. And in November 26, we submit a project to FAPESP, join many collaborators from Brazil and from other countries. In January 2014, we had the project approval. It takes long time, but I'm not going to tell about the details. And then after we have the project approval, it goes very fast, asking for the perform invoices. We had a launch of the project in the beginning of last year. In July, we had the definition of the sites, and October, November, the equipment starts arriving, and then we installed one station in the center of the city. People are going to talk about this in more detail. And we already had measurements at IAGER, our institute, and one station, one mountain in São Paulo. And in January this year, we had the launch of the website. In the project, we had bought some equipment for greenhouse measurements and for this isotopic analyzer from Picarro. Also some two meteorological towers, black carbon measurements, one F-tier, EAM27 centimeter, and a cluster for computing also. Then with these equipments, we start to have this network. I know it's not a really great network, but we are going to have 5 sites measuring these greenhouse gases at the same time. Then the experiments that are being performed, we have the 4 sites already, one to be installed, but more detail will be presented today. And tomorrow, we are going to have some presentations about the emissions factors, the aerosol measurements, and also the modeling that is related to the description of the emissions, the vehicular emissions, that we have more experience, and also what is being doing related to the biogenic and biomass burning emissions. Until now, the transport models that are considered, WRF CAN, and the idea is to have this WRF JG and the trajectory modeling. This also will present tomorrow. Well, this is what I like to say. I wanted to do this introduction, and I would like to invite Professor Paulo Artaxo, that's going to talk and explain the relevance of this project in the context of FAPESP research program on global climate change. Please, Paulo.
Yeah, hi Fatima, and hi everybody. So Fatima, I have to stop presenting.
Yes, I am.
Yeah.
Okay. It's because some people are asking. Sorry. Okay. That's okay.
Okay. A window. It's starting. So basically, are you see my presentation?
Yes.
Okay, so basically, sorry, it's in Portuguese, the version we have right now. So this is the new scientific plan for the FAPESP Global Change Program. So basically, we designed over the last 2 years what FAPESP should fund in the next 10 years, 2020 to 2030, in several different areas. So basically, the scientific plan have to do with the energy policies and socio-economics issues, modeling of climatic and also environmental modeling, biodiversity and ecosystems, land use change, and food production, that is a critical issue for Brazil. Then the topic number 5 is urbanization and climate change. Topic 6 is health and climate change. social and economic dimensions, and so on. So basically, what we are planning to do in terms of urbanization and climate change, I will go straight to that part of the project. So if you want, I can send you the whole scientific, for the overall email of METROCLIMA, the whole science plan. We are doing weekly seminars, webinars now, discussing what we are proposing as priorities, what we are proposing to do with the scientific community. Urbanization and climate change will be in 3 weeks from now. Of course, we're going to invite Fatima to be one of the persons to make critical analysis of the plan. But basically, what we have, we designed 7 priorities on this particular area. So the first one is solution for the issue of mobility in the big and average size cities, meaning to reduce the greenhouse gas emissions and also air pollution, protecting the health of the population. So this is the first topic. Then the second one have to do with the legislation that in Brazil is something that is very critical also. So basically to make smart plans for the strategic directory plan for all cities, including soil use, occupation of the soil, also edification, and so on. The third one is dealing with the development of intelligent and integrated systems to integrate the infrastructure of the city to use of energy, to climate, to transportation, edification, logistics, distribution of foods, and so on and so on. The fourth topic is the segurança hídrica, so basically is the water security for the big urban centers, not just in São Paulo. This is becoming a very critical issue for many medium-sized cities. So we develop more policies for use and reuse of water, and then provides water with quality. Number 5 is the reduction of air pollution in the big urban center, in particular gases and particles with the climate impacts, like the short-lived climate pollutants, aerosols, black carbon, and so on. That's number 5. And then we have 2 other topics. The number 6 is the research in urban ecology. So basically how the global climate change and global warming is affecting the population, the health and the well-being of the people, and then discussing the environmental services provided by the urban biota. And the last objective is to develop a process for the management of solid waste and also liquid waste, and also urban and population, urban and industrial in all the big cities, with the opportunity for job creation for persons with the low qualification. So basically this plan deals with the greenhouse gases, air pollution, solid waste, and the main issues that we identified in terms of needs for research. In addition to that, of course, the health and climate change topics also address the issue of the urban air pollution and regional air pollution in the big centers. So basically we are discussing this in several webinars. Actually, we are planning for 7 webinars. The first one was last week about the use of energy and how to develop the strategy for a sustainable energy production and use, not just in big cities, of course, but for the whole Brazil. So I invite you to participate in the webinars. I will send it to the whole group, the dates of all the webinars in particular, as well as this preliminary plan. The idea of these webinars is to collect the suggestions from the scientific community to improve the plan, and then the final plan that should be ready in about 3 months will be submitted for the Superior Council of FAPESP for approval, and we start to implement it in January next year for the next 10 years.
Hi, Paulo. Thank you. Thank you very much. Please don't forget to share this agenda. It's better because we receive a lot of emails and then we don't pay attention to all the emails and to all the webinars that we are invited to, but they are very important. Please share with us.
Okay.
And now, I would like to invite Dr. Eduardo Landulfo, that is going to talk about the sites and the measurements that we have already performed.
Okay, so let's see if I can make my presentation available. It's always a challenge. Okay, right. So first question is, do you see my screen? Do you?
Yes.
Okay.
Yes.
Okay, now I expand it, okay?
Okay.
Okay, so I will talk about the GAG soundings, the site selection strategies that we have been using so far. I'm Eduardo Landulfo, and also this work is in together with the METROCLIMA members. So just a brief background, historical background, recent historical background. As Maria de Fatima showed to you, it took some time to get the project approved. So after after 2 years, more than that, and then after the assignment of the contract with FAPESP, we made like a visit to LA. It was me and Dr. Marcia Yamasoe, because we want to know the sites, how they were installed, to get more feeling how we should proceed, and of course also to get to know the instruments that we have been using. The calibration was an important aspect as well. And also we took the opportunity to meet with the Picaro representatives to make the final selection for the instruments. And this visit was guided by Bill Angel at that time, and he was a member of Earth Networks, and he guided us from some of the sites in LA. And then after that, we decided for the Picaro, the FTIR, and the cluster, and also other instruments like the oscillometer and so on. After this system have been acquired, we started doing the system installation, and also taking care of the calibration and how to proceed with that. And of course, those actions were more or less parallel with the site selection, because every site has its own features, so you have to adapt and so on. So the site selection we took into account logistics, representation of the data that will have been acquired, and so on. So the first aspect would be like the geography of the city. So the greater São Paulo, considered like a mega city, and it has like the area that we'd like to cover. Maybe it could be more than that, maybe it's less than that right now. It's 86 by 42 square kilometers. And then it should, and you'll see that it has very different patterns over the area. And one key aspect that we took into account was the proximity of the city to the sea. We're about 56 kilometers from the sea, and we are above the plateau, more or less like 800 meters, less than that, most of it. You know, with a lot of influence of the sea breeze coming from the southeast. So the selection that then we have made was the Jaraguá Station, IAG USP, ICESP, Unicity, e Cientec. So from the pictures you can see they have some own features like being outside from the city. IAG USP, for example, is like a mix, like a green island. Unicity, ICESP are both very urban sites. And then Cientec also is like not apart from the city, but has a lot of green area as well. So the idea then, when you make the comparison with the sites you had visited in LA, was more or less like that. Unicity is said to correspond to the USC, very close downtown to LA. Caltech, we admit, like, it seems that to have to be the same pattern as USP. San Bernardino would correspond to Jaraguá, and maybe Canoga Park with ICESP. But it's just, you know, it's just like a correspondence, just to give a flavor to our colleagues from LA to know what we're more or less dealing with. So IAG was selected for many reasons. Was not for geography, because you see that is down to the valley, but it's in the university. So we have all the facilities, the logistics, and also from now we're using that for our calibration center, so to speak, so we can put everything together there, especially during the pandemics, because you cannot go anywhere that you want. So you have to assemble or to correct something. We try to do that, even though that we have some restriction to get to the university. The site is about 10 kilometers from downtown, the city center, and most of the activities have been done here so far. Now, then you have Pico Jaraguá, which is the farthest site, about 17 kilometers from downtown, and it is the highest as well. As you can see, it's about 1,000 meters, which for us is high enough. Okay. So ICESP, it's very near to the downtown, about 4 kilometers, and it actually is installed in the, let's say, in the top of the plateau, so to speak. It's installed in like a hospital center and on the top of the building. One thing that I would like to call to your attention, especially here, is that it's just a remark that here is Pacaembu, which is in front of the Charles Miller Plaza. So maybe, as the Charles Miller was the guy who brought soccer to Brazil, which we call football. Okay. So then we have Unicity on the east part of the city, about 7 kilometers from city center. It's on the top of a building as well. It's like a private university, but it's also in more or less in the same plateau. But you see, you don't have many gradients in altitude. Okay, but I mean high gradients. You do have gradients, but not very high. But it's on the other part of the city that has a different aspect, and maybe also a different meteorology pattern as well. And then the last one that should be is planned, is not operational yet. It's Cientec, which is in a very green area, as you can see, because you have the zoo, and also here it belongs to the University of São Paulo. You have a lot of climatological data, so that's very important to use. and also it's very close, at least is on the southeast of the city, and should be very impacted by the sea breeze and things coming from the seashore. And normally you have a lot of fronts coming from this way. So our deployment so far, here you have the site list, the coordinates, and the altitude. So the instruments, until now, they were deployed at USP, the concentration and the isotopic. The FTIR is also installed that. We have a LiDAR very close, and we have a lot of data from the meteorological stations in the building. In the Pico do Jaraguá, you have also concentration in the air quality station close by. Actually, we are more or less sharing the same place. And then Unicid, you have also the concentration, but with also CO measurements. At ESASP, you have the flux measurements with an anemometer. And then at CNTEC, you have concentration measurements of methane and CO2, and you got some working together. Also at CNTEC, you should have measurements of wind, because there is also, like as I said, it belongs to IAG in USP. So here is some comparison that we had the chance to make with the ceilometer in the LiDAR, just checking how they behave, because you want to deploy the ceilometer somewhere else, because the LiDAR station is like a fixed one. So we have at least two points in the city where you can measure, you can monitor the PBL height. And also the comparison so far is not very bad. And but we still work on that. That was done during this period, like the 6 months, in the 6 months ago. Also, we are taking care of, also using the satellites that monitor methane and CO2. And the three main missions that we are involved are GoSat, OCO2, and Sentinel-5P. And of course, what we're trying to is to merge all these measurements, because they have different overpasses, and also to compare them among themselves, and try to also to check with the modeling and in the ground measurements that we're going to be doing. Here, just like some of we gathering the data and visualization, and that's what we're using for like tools for 5P, GoSat, and actually some of our colleagues from JPL are here as well. We would like to know more how to get the data from OCO2, and as it didn't seem to be so straightforward as the other were. Okay, so that's what I have to say. Thank you very much.
Thank you, Eduardo. And now, following our program, I would like to ask Diogo Medeiros to do his presentation.
Right. I'm going to load my presentation in just a second.
Thank you.
Can everybody see the presentation?
Yes.
Cool. So, yeah, so today I'm going to be presenting some of the results that we've been getting when trying to calculate the integrated columns of a few greenhouse gases in the metropolitan area of São Paulo using ground-based FTIR measurements. The results are very preliminary, so I would recommend to take these results with a pinch of salt because they definitely need some refining. But they look promising, so it's worth having a look at them. I've tried to make this presentation very objective, so if someone's got would like to get some details of what we've done, that's my email right there, diogojmedeiros@gmail.com. So you can drop me a message and we can proceed from there. So in this presentation, I'm going to give you a very brief site description and instrumental description as well, and how it works. I'll show you the preliminary results that we've got, and I'm going to wrap it up with a list of things to do next. So starting with the site, for those of you who are not very familiar with Brazil, the state of São Paulo is in the southeast of Brazil, and the metropolitan area of São Paulo is going to be highlighted in red right now. If you can see the red circle. And if we zoom in, this is what the metropolitan area of São Paulo looks like. It's consisted of 39 cities, and it's very important for the economy of São Paulo. São Paulo itself, the state of São Paulo, is the economic center of the country, and it's responsible for about 35% of Brazil's GDP. And in terms of manufacturing, the metropolitan area of São Paulo is responsible for more than 50% of São Paulo's manufacturing GDP. So now I'm going to highlight the place where we're taking the measurements at the moment within the metropolitan area. So roughly it's where the red circle is. Professor Eduardo showed the coordinates for the IAG, which is where we are. This is where we are temporarily taking measurements. The instrument that we use is going to be transported to another place soon, but for now we're taking measurements right there. I'm going to discuss about why we're going to be moving it somewhere else when we're seeing the results. But yeah, here we've got a few facts about the metropolitan area of São Paulo. It's got a total area of about 8,000 kilometers, more than 21.5 million inhabitants, and more than 7 million vehicles. And the majority of these vehicles are fueled with a blend of gasoline and ethanol, something that makes this measurement site very intriguing and peculiar because of the high consumption of ethanol within the site. So proceeding with the instrument, this is a picture of the instrument that we're using, taking measurements. It's a FTIR spectrometer from Bruca, version model at EM27/Sun. So it's a spectrometer coupled with a solar tracker. I'm going to show you another picture of it from a bit far away. It's located on top of that structure. This picture is just to show you where it's, just to situate you a little bit better. So it's on top of that structure. It's a bit hard to see with all the aerials around. But yeah, that's just to give you an idea of where it is. It's got a maximum resolution of 0.5 reciprocal centimeters. And this is a picture of the solar tracker. This instrument is actually very cool to watch it while it's taking measurements. It's very automatic, and it's very cool to watch it following the sun as the day goes by. The mirror, which is right in front of you, it's got an axis connected to a motor that allows for the correction of the solar elevation. And the blue disk that you can see rotates, so it's possible to correct for azimuth changes during the day as well. And the way it does this sort of correction by moving the mirrors is by using a camera that is located inside the instrument. This is the image of the camera. These are examples of the images of the camera. The dark holder that you see is the aperture of a field stop. And you can see the solar disk being projected on top of the aperture. The figure on the right-hand side represents a better alignment of the mirrors, because you can see that the solar disk coincides very well, the center of the solar disk coincides with the center of the aperture. The figure on the left, there is a little bit of a displacement. So this displacement, this shift of the center of the ellipses that you're seeing is what the software is using along with astronomical calculations to correct and move the mirrors so that the situation on the right hand is reestablished. So you have a good alignment and you have a constant signal. So yeah, let's jump into the results that we've got so far. This is an example of a spectrum collected with the instrument last week, on Thursday last week. the afternoon. This figure shows two different colors because the instrument the detector has a second channel that allows for the detection of CO, and it's often referred to the CO channel, the red. The blue is the first channel. I just wanted to show you an example of the spectrum collected with the spectrometer. This is where the pinch of salt needs to be taken into account. So this is a comparison of data we've collected with the FTIR. So I've analyzed the data using an atmospheric inversion algorithm called ProfFast. And the reason why I chose that one is because it's very user-friendly and accessible. You can just download it from going to their website, and it's just a direct link. There's no registration necessary. And it's very, very straightforward to use. Now, so yeah, let me just go back here. So basically, the process that transformed this spectrum into the integrated columns is what we call the atmospheric inversion, which is spectral fit using a priori information. This graph shows a comparison of the integrated column of water that we've collected with the FTIR spectrometer, and the black information in the graph is actually taken from the AeroNet. For those who are not very familiar, this is a federation of networks which is very well established over the years, and it provides lots of interesting data. And among them, you can get spectral, aerosol, optical depth information. You can also get precipitable water concentration. So we've got the info from the website. It's easy to access. And this graph is just showing a comparison about the columns that we with the two sources. The thing is, we're not incorporating surface pressure measurements in the analysis that we're doing. So that is an important parameter to be taken into account when you calculate integrated columns. We've been in contact with students of Frank Hayes' group from the Karlsruhe University, Karlsruhe Institute of Technology, and we're following some of their advices on this. And that was the specific recommendation that they gave us, to incorporate surface pressure measurements on the analysis, and that should help things out. But measuring water vapor from FTIR, from ground-based FTIR measurements, is a challenge on its own. So the most important thing that I would take from this graph would be the intraday variability, which is quite consistent. And the fact that we're not seeing something absurd in this graph, and the fact that we've started these measurements not long ago, I think this is a good indication that things are in the correct direction. Definitely, we need to learn more and familiarize ourselves a bit further with the instrument and the analysis. But it's good to see a good match between the intraday variability. This is a measurement from last Thursday. It's the same story, same thing. I'm not going to spend much time speaking about this one. The spectrum, so from the inversion, we can also get info that is very important, like the column average dry air mole fractions for the greenhouse gases. This graph is showing the values that we've got for the 2 days of measurements that we've done. This info is very important because it can provide a validation data set for satellite retrievals. Yeah, I just wanted to show you some examples. I've checked in the literature to see if these numbers were not absurd, and yeah, I found numbers in that sort of order of magnitude. Nothing looks absurd. There's no red light here, so I think it's a good indication that we're doing things appropriately. However, the student just mentioned, the PhD student from the Karlsruhe Institute of Technology, Carlos Alberto, he's also going to be analyzing the data, our data, which is going to be a very good opportunity to cross-check the results to make sure we're doing things correctly. Same sort of results for methane for 2 different days. Again, I checked against the literature, nothing absurd in the numbers. And same thing for the dry air mole fraction of CR. This is just to show you again that the orders of magnitude of the things that we've been collecting, they don't look very nothing strange. But again, it's hard to make any conclusions about the results that we've got so far, since we have so much limited data being collected. But things should get better soon. So for the future work, the plans that we've got at the moment are to cross-check the analysis with KIT, as I just mentioned. There's somebody working on that already. We would need to complete the registration to the TCCon system. That is necessary because it's from their system that we generate a priori profiles for analyzing for performing the atmospheric inversion. And but I've contacted them already. They said they're changing the website and the software version, and I'm on the hold for now, so I should be waiting for about a couple of weeks before contacting them again. The GGG package that is cited there is the package that is provided by the TCCon team, and it contains a fitting algorithm named GFIT, which is very popular as well. It's used by the TCCon network. Also, it's important to familiarize ourselves with the instrumental calibration because we're doing a spectral fit in this work. So if we are constructing synthetical spectrum, then it's very important to make sure that the instrumental line shape is correct. We've been in contact with Bruker, and they are probably going to provide us a way to do some training for this. It's part of their agreement when they sold the instrument. And finally, to transport the instrument to the Science Tech Center, the reason is because in there we're going to be able to have access to, this is one of the reasons, not just one, but the infrastructure is pretty good there, and we'll have access to intraday pressure and temperature measurements in there without much hassle. So it's definitely gonna improve the accuracy of the numbers we get out. But yeah, we're still on the stage of familiarizing ourselves with the instrument and the analysis, but the numbers and the results we're getting out are promising. They look fine, but we need further investigation on the numbers to make sure everything's being done correctly. And that was it for me. Yeah, thank you for your attention. It was a pleasure to talk to all of you.
Thank you, Diogo. Thank you very much. There is a comment to you here, but after the presentations, we can discuss.
Okay, let me just stop this.
See the comments in the chat. Now,
Yeah.
Now I'd like to ask you, Marcia, to do her presentation.
Hello. Okay, I will load my presentation. Just a second. Okay, can you see it?
See, Marcia.
Okay, great. So thank you, Fatima. Good afternoon, everybody. Thank you very much for the interest in this first webinar of the METROCLIMA project. My name is Marques, and I'm working in this project as a research technician. I've been working directly with the greenhouse gas stations, or GHG stations for short, and the data that's being generated. I will not dive too much into detail about the data or specific results, but I would like to give a general idea of the set of data we have available so far. This is an emblematic picture of the city of São Paulo. It's also the cover of our website. The picture shows an important commercial area in the southwest of the city, near Pinheiros River. It's an example of the urban setting of the city with densely packed tall buildings, and it's also a possible location for our next mobile campaigns. I would like to start with some quick facts about the city. As Diogo also said, São Paulo is the most populated city in Brazil with an estimated population of 12 million. According to the inventory released by C40 in 2017, São Paulo was responsible for emitting more than 15 million tons of CO2 equivalent, occupying the 29th position on the list. The city also has more than 8 million motorized vehicles, according to the National Traffic Department in 2018. Although we had some recent changes in policies regarding the quality of fuel and control of emissions, traffic is still a huge contribution to the city's emissions. São Paulo is anchored to the São Paulo metropolitan area, or the São Paulo metropolitan region, which consists of 39 municipalities and an estimated population of more than 21 million, which makes it the fourth biggest megacity according to the United Nations in 2018. Just to illustrate, this is the state of São Paulo in the southeast of Brazil, in the metropolitan area I mentioned with all 39 municipalities. And as Eduardo showed, this is our JG stations. São Paulo is located at approximately 706 meters above mean sea level and 60 kilometers westward from the Atlantic Ocean. The climate is characterized by a dry winter from June to August and a wet summer from December to March. Although São Paulo is not a coastal city, we do have a strong influence from the sea breeze that reaches the city half of the day of the year. The sea breeze usually brings cleaner air, but it also causes unfavorable conditions for the dispersion of pollutants. Here, these are our current GG stations. In blue, the stations that are already in operation, and in gray, in the south of the city, we have one more station planned. Hopefully, it will be ready next month. Well, before showing any values, it's important to mention that the data is currently being verified with standard gases accredited by the Brazilian Calibration Network, but no corrections were applied yet. Carlos will talk a little bit more about that later, about the calibration strategies later. For this set of data, I am using the factory-corrected dry mole fractions from Picarro. When we set up the first stations, we are using silica dryers to dry the air sample, except for the one using the Earth Network equipment that uses a naphtha dryer. But the silica dryer was not efficient and it demanded frequent replacements. Not all the sites have easy access, and we weren't able to keep the water vapor concentrations stable, so we decided to remove the silica dryers. We will use naphtha dryers that are more efficient, as I said, to dry the air sample, but for now we are using the factory-corrected dry mole fractions. Quality control flags and filters were applied to the data, mostly related to maintenance events. As I said, not all stations have easy access, and we have more restrictions now due to the current situation. Most of our data collection is still manual, and it has been quite challenging keeping everything running with all these restrictions now. But we try to update our stations weekly to ensure everything's working properly. These are only a few examples of the quality control filters, and all data is transferred to a Linux server at the university, and it's made available for all researchers and students via our website, so they can have easy access. And an interactive dashboard is being developed to show some quick looks and preliminary results as well. Well, this is the Jaraguá station. As Eduardo mentioned, it's located at one of the highest places of São Paulo in the Jaraguá Forest Reserve. And it's where we have less influence from anthropogenic sources. Carlos will also talk a little bit more about the background levels estimation regarding the site. Here we have the box plots of daily average concentrations of CO2 and CH4 from January to the end of last month. For this site, we have data from previous years, but for this year, CO2 concentration was 416 ppm and CH4 around 2 ppm. These are the lowest values compared to all other stations we have in operation right now. The next one is the station in the campus of the University of São Paulo at the rooftop building of the Atmospheric Science Department, where we have other meteorological instruments operating as well. We also have data from previous years from another instrument that is under maintenance for now, but with this new setup, we have data available from the end of March until the end of last month. Concentration of CO2 for this period was 427 ppm and CH4 2.12. These are intermediate values compared to other stations. This station is in a suburban setting of the city. We have the influence of traffic emissions, but we also have vegetated area around the campus. We also have an isotopic analyzer here, but I will not show specific results about that. The next station is in a typical urban area of the city. It's located at the rooftop building of a private university, Unicity. It is where we have higher values of concentration. We have that available from December last year. CO2 for this period was 430 ppm and CH4 2.16. This is the only site where we also have carbon monoxide measurements. It's worth mentioning that in this site, we had unusually high concentrations of CH4, mainly during the late night and early morning. We are still not sure about the possible sources, but we are investigating it. The next one is our most recent one. The site is also located at the rooftop of a building. In this case, it's a tall building with more than 100 meters, and it's located near Police Avenue, also in a typical urban setting of the city. We still do not have one complete month of data, but we expect to see some interesting results. As I said, for the next month, we have planned one more station in the south region of the city. This station will be located in the Science and Technology Park of the University of São Paulo. And here is where we have the meteorological station operating since the 30s. Well, I will not talk about other pollutants, but I think it's worth mentioning the network of air quality measurements stations from the environmental company of the state of São Paulo, CETESB. That is also contributing to our project. Most stations measure particulate matter 10 and 2.5, ozone, nitrogen oxides, carbon monoxide, and meteorological parameters. They have several stations over the metropolitan area, and all data is available on their website. The Jaraguá station I mentioned is located in one of their air quality stations. We also have a micro-portable gas analyzer from ABB that will oscillate with measurements in different points of the city and will contribute to verify values from vehicular emissions. This is just an example of the first test we performed inside the campus of the university. The idea is to do short measurement and campaigns, both to verify possible locations for implementing new JG stations and to help characterize different areas in the city. This is an overview of data availability for all the stations. As I said, we do have measurements from previous years for the Jaraguá station and IAG station, but I will only refer to this year's data. The shaded areas indicate the season, somewhere at the beginning of the year, and now we are almost at the end of the winter. We compare data from the three stations, Jaraguá, Unicid, and IAG, for the indicated period from the end of March until the end of last month. Here we have the diurnal variation of the period mentioned for CO2 and CH4. Both concentrations vary diurnally due to the influence of emissions activities and meteorological conditions. As I said, Unicid has higher values. In this station, hourly average CO2 concentration is higher during the morning, around 8 a.m. local time, which can relate to traffic jams, and lowest at 3 p.m., with a peak-to-peak amplitude of 20 ppm. IAG has intermediate values. CO2 concentration is also higher during the morning, with earlier peak at 6 a.m. and lowest also at 3 p.m., with a peak-to-peak amplitude of 26 ppm. Here, we observe higher values during the night and early morning, even higher than Unicid, that is in a more urban environment. It could be associated with contribution from local vegetation during that time and traffic of heavy vehicles during this time on Pinheiros Highway, 1 kilometer far from this station. And as expected, Jaraguá station has the lowest values, and the peak-to-peak amplitude is only 10 ppm. When we look at the patterns on weekdays and weekends, we expect to see higher values on weekdays, mainly during the morning, related to the traffic emissions. The difference is greater in Unicid station, that is located in a building near important avenues. And in other stations, we also observe higher values during the weekdays, but the difference is smaller. CH4 concentrations did not show obvious differences. In this case, anthropogenic emissions associated with this pattern are not the main sources. About CH4 sources in the city, we expected to see the influence of solid waste disposal, wastewater treatment, and also natural gas used for cooking. As I mentioned, we observed high values of CH4 in Unicid station during the late night and early morning, but we are still investigating the possible sources. An important next step is also to link this behavior with variations in the planetary boundary layer. We will have 1 oscillometer operating continuously in one of our GAG stations, and we also have LiDAR measurements at the university campus. It's important to say that this has been a very unusual year because of the influence of lockdown. Although we did not have a complete lockdown and most of the activities are back now, we had an impact on the city emissions behavior, and Carlos will show some results about this event later. As I said, it has been a typical year, and further analysis needs to be done, and of course, other parameters need to be taken into consideration in this analysis as well. But I hope I have given you a brief overview of the data we have available so far. As my final remarks, I would like to mention our website again. Most of the information is available there, including interactive graphs with hourly and daily averages of GHG concentrations. Not all the stations are updated yet, but soon all data will be available. And thank you again for your attention, and I will hand it over to Carlos.
Thank you, Marcia. Now, Carlos is going to
Okay,
present it. Okay,
show my. Okay, you can see me.
Yes.
I put my screen. Okay, you can see my. Yeah.
Sim, Carlos.
Holy. Let's see. Okay.
Sim, estamos vendo, sim.
Okay.
Thank you.
Good. Hi, everyone. Many thanks for attending this webinar. I will briefly show preliminary results of the first semester of surface measurements of CO2 and CH4 concentrations in the main 3 stations in operations right now. I'm Carlos Oliveira, postdoc position in this project. Okay. Let's see. Sorry, I have a little problem with my presentation. Let me see now. Okay, sorry for. Inside the quality control strategy, there are our calibration strategy to traceable measurements. First of all, we have GHG equipment implementation. Currently, we are using in-house government standards traceable to calibration network. Brazilian calibration network. And on the last 2 weeks, have arrived for us the international standard from NOAA to measure and trace our gases against international scale. Using similar strategy that have been used in LEA-based GHG network strategy, and our in-house standard will be used as target tank, similar to this strategy. Now a brief overview about the main sources of GHG gases in São Paulo City based on 2017 inventory. Transportation is the biggest source with emit high levels of GHG gases, mainly CO2 gases as well, followed by stationary energy and waste landfills and this kind of source that are an important emission of CH4 gas. Seeing the lockdown impact on the city on GHG emissions, we have observed more impact on transportation changes, considering restrictions of mobility in the city, and you would the first analysis about this impact on GHG concentrations in this period. Okay, firstly, this graph show CO2 weekly distribution for Unicid and Jaraguá stations. Unicid have the highest values as introduced by Marcia, while Jaraguá station have the lowest values of CO2 ppm. And specifically on the lockdown period, we have the for peak no very high change. The most change occurred for Unicid and EAG station, as you can see here, for CO2 diurnal cycle. Here you can observe the early distributions for CO2 concentrations in Unicid stations for normal days or regular days. And here the CO2 concentrations for during lockdown period. You can see a difference most marked in rush hours, the first and second rush hours, and at night as well. These concentrations are different of lowest values for Jaraguá station, that our station candidate to background site. Here you can see difference between CO2 concentrations for normal days in EAG station, and here with lower values for normal days and for lockdown days with lower values as expected. And at the same point, Jaraguá station with lower values. It's important to mention that these higher concentrations are linked to vehicular emissions in the rush hours, and at night with vehicular emissions and respiration as well. While in the midday, we have the main sink of CO2 that related to photosynthesis process and biological activity. Here we have the C84 weekly distribution for Unicid and Jaraguá stations, with as expected Unicid with higher values, while lower concentrations in orange for Jaraguá station, and no clear difference between lockdown periods and other normal days. As Marcia have mentioned, the lockdown is not exactly, it's occurred gradually, but these days, as the red line can be shown, it's the more mobility restriction. Because of this, we choose this period. Here, C84 journal cycle for to Unicid station compared to Jaraguá station. During normal days, Unicid station have the higher concentrations. Interestingly, lockdown days have similar values of CH4 ppm concentrations like Jaraguá station. For EAG station, normal days have higher values, lower than Unicid, but slightly higher than lockdown period and Jaraguá station concentrations as well. Okay, to try measure influence of vehicles to CO2 emissions, we we observed carbon oxide, CO concentrations and correlations, considering that CO is an important vehicular tracer, very used to trace vehicular emissions. It's interesting to observe that CO concentrations variability in orange color have very lowest values during lockdown period, while CO2 concentrations have lower values, but higher variability. Observing the correlation between CO2 and CO, you can extract some important information about the vehicular emission source and other source and process that control CO2 emissions and sinking, source and sink in different sites. Here, for example, we have a good high correlation coefficients for IAG and INCID at night and rush hours, but these correlation coefficients decrease to very small values like in IAG during photosynthesis process, considering this very important sink of CO2 in city. It's important to remember that IAG, it's a suburban vegetable site, while Unicid is a very high urbanized area with faulty vegetation practically, and as well slopes have specific variabilities during the day and during different source and process actually in the CO2 control. Using slopes intercept is important information about background values of CO2. We use this equation that have been used in other works, like in Beijing site, to estimation of CO2 concentrations background in these sites. Here, these values of background estimation in gray color for Unicid and blue color for IAG background. It's interesting that this background estimated is very similar with the concentration, CO2 concentrations to Jaraguá station. That is our background candidate station. And the values for Jaraguá station during lockdown and normal days is very similar as well. While CO2 concentrations for normal days in Unicid and IAG station, it's very high. Using difference between background values and concentrations for hourly averages, you can estimate CO2 excess to these surface measurements. Okay, you can see to Unicid that difference in CO2 excesses during lockdown in black and, in normal days in black and lockdown in gray color. The higher difference are at night and during rush hours. These reductions are estimated about 60%, while for IAG station, the reduction estimated about 43%. It's important to mention that is the preliminary results, preliminary estimations needs improve with more data. Here there are some months of data, and so we need at least a year of data to better estimation. But these estimations are in line in this potential reduction during lockdown time, in lockdown period that occurred in April mostly, are in line with a reduction of gasoline sale during April compared to 2019 to 2020 to final consumer. These data are from Petroleum National Agency, and we can estimate with this gasohol reduction similar reduction of 0.85 kilotons of CO2 emitted by month during lockdown month. If you extrapolate this lockdown characteristic for whole year, you can reduce 10.2 kilotons of carbon by year. Okay, my final remarks, some perspectives and challenges of our project. The first of all, implementation of GAG surface measurement network, and traceability to international scale that is in progress. As well, estimation of source and sinks of GAG gases using integrated tools like concentrations, isotopes, flux, column measurements, satellites, meteorology, wholly model. And another important goal and perspective is related to monitoring real impact of GAG reduction policies adopted by governments of São Paulo on GAG atmospheric concentrations reductions. Remembering that São Paulo has signed Paris Agreement and have important goals to GAG reduction strategies to 2030 and 2050 years. Some acknowledgements for FAPESP Foundation of the project and the scholarships. Unicid by professors Agostinho and Yuka by helping in the Unicid station. Cancer Institute to help as well to GAG station, and the environmental company of São Paulo State that help very much with many things. Many thanks for all, and I'm available to additional questions.
Thank you, Carlos. Well, it was amazing that we are just on time. We are not. We have no delay. And then I would like to open for questions and comments. I see here that there is a comment from Charles Miller about the daily drawdown of the urban CO2 signal during the lockdown. This comparison, normal and lockdown periods. I think it's really amazing that they are so different. Yes. Can you see, Carlos, in the chat?
Okay, let me see how Charles Miller.
Yes, because we don't think the large delay in the daily.
Correct. So one of your early charts, Carlos, showed that there was a dramatic, maybe 4 or 5 hour difference between the daily minimum in the CO2 drawdown from the lockdown versus the regular periods?
Yeah, let me put the graph. Let me share the.
Even a 1 or 2 hour shift would have been remarkable, but you were seeing many, many hours of delay.
Sorry, I'm not getting to share my window here. Okay, I think that.
No, not yet, Carlos.
No,
Okay,
not.
Now it's okay.
Yeah, it's okay. Okay, what slide? This difference.
No, Carlos. The two first ones, I think you showed the comparison. I mean, probably, yes.
Okay.
Correct. This was the chart that I was really surprised.
Yes, for us too.
Could you put in the presentation mode to be
Okay. Here.
For us to
Okay.
see? Okay, thank you.
Yeah. May I make a comment, Carlos?
Yes, this we can we could maybe expect this, considering that the Unicid station it's very remarkable by vehicular emissions. Because of this, we can see a clearly difference between lockdown and normal days in concentrations. I don't know if I have answered.
Yeah. I'd like to make a comment. I mean, you see that the avenue here, and it's a very heavy traffic, and it starts like 4, 6 in the morning, goes until 10 in the morning. It's really because there's a large amount of the population that lives in that area, and they go downtown or even to the other side, the west side of the city, and it's like this one, and also not far from here, you have another like turnpike that's not very far from the city as well. See, this is also one concern that we have, that the site is good, but it's very affected by the local traffic. But there was we're getting data from that, but we see that it's very affected somehow. And that's why you have such like this drawdown that you said and the delay, because you have cars for a long time going on from the east side towards the center.
Another important observation is related to lower values of Unicid during midday compared to EAG, considering the features of very high urbanized sites, Unicid, and EAG vegetable site, considering the difference between the midday values, concentrations values to Jaraguá, that's our background, forested site, and the EAG very close values during midday. I think that we can we can see clearly the features of site urbanization with data. We are very happy with this data. You can see a good replication of the urbanization degree with CO2 concentration distributions. I think that is a surprisingly and interesting observation. I don't know if we get to answer the question.
Fatima. Yes, thank you very much. The explanations are valuable. from your work with the air quality, do you already have access to the vehicle traffic data?
Yeah, we have to see only CO at the moment, but we will need to make future comparisons with other pollutants, air traffic of air quality stations, CETESB air quality stations, pollutants to see these relationships.
And also we have data about the traffic. It's not with high resolution, but we have data related to the light and heavy duty vehicles during this period to check the information about the reduction of the traffic. But it is true that it is very impacted by the local emissions. We don't know, but maybe it's good to have this kind of site that is very related to the local emissions, and then the answer is very fast concerning the emissions that are at that point. I don't know if you have the same in California, or I don't know if you have this kind of lockdown that you could notice some difference so fast, the difference between before and after the lockdown related to these CO2 concentrations.
Yes, we saw approximately a 30% change in the CO2 signal in the period after lockdown. I think Vineet was online earlier. He's done some wonderful analysis with this, and by looking at the time series, is able to actually identify within a few days when people actually began modifying their behavior dramatically.
Yeah, that's nice. Well, Teotoni made a question here, or observation, that about the background difference could only be related to the altitude of Pico do Jaraguá and the AG background, because it's more than 300 meters, the difference.
Okay, here. Yeah, maybe you need to see more data about it, like bondar layer height and other informations, but interesting observation that background concentrations estimated to Unicid station and the IAG station with similar altitude heights is very similar with concentrations of Jaraguá station. If you think, I don't know if colleagues can help me, but if you think to bondar layer, to Jaraguá station is lower bondar layer considered heights. I don't know.
Yeah.
Né?
I mean,
maybe it would be more concentrate.
This is one aspect. Could be not the dominant, but also you have to check about the circulation, air circulation. It's one important aspect, but by all means is the one that's not is less close to the city, even though you have like a major highway passing by not so far, and still we think that from the moment this is our background. Maybe if in the future we have, let's say, funding, and also we could deploy in other place, like a higher place, and also in the northern part of the city, that could be, we could make the difference. So in one aspect, this is our first candidate as a background, but especially because it was during the lockdown. Maybe during like a normal year, that's not going to happen. But you have to see that happening. I mean, that changing. That's our concern. So the summary is, since everything stopped for some time, like 3 or 2 months at least, perhaps, or most probably, most likely, Jaraguá Peak was the less affected by the pollution and the emissions from the city, because was the one that was farthest and so on. So that's one thing, but that's a try. That's not the final candidate, the ultimate candidate, but that's the start.
Yeah.
Yeah. There is another observation that it would be interesting exercise to compare the hourly, I think is a standard deviation between the periods. Then you may avoid any seasonal influence. Is it for standard deviation or for another thing? This the
About the standard, we have adopted a confidence interval for this strategy, considering standard deviation and the number of measurements data. We have observed that the Jaraguá station has the lowest standards and the uncertainties compared to Unicid and IAG station. This is expected considering that we don't have main source in Jaraguá or lower source contributing than to other sites. This is the main observation.
okay. More questions? I don't know if someone wants to ask. Okay.
Can I stop my presentation, Fatima?
Yes.
Okay.
Yes, I think. Okay. If someone wants to ask in Portuguese, it's okay, because then we translate for everybody. Tiago.
Okay, good question, Thiago. We don't have this comparison yet, but it's a very interesting comparison, the slopes and intercepts between lockdown and regular days. Another important information to combine with slopes is isotopic data. We are measuring isotopic data, and we need to make some validations and assess this data to combine with concentrations and other important data to talk about source, the main sources and the main signatures that you can observe in São Paulo. In this point, slopes and isotopic data will be very, very important information.
And also we have this data from the previous years that the problem is that it was not calibrated accordingly to what is expected. But we have the verification of the data, and also we can compare. It's good because it's a long period, and then at least for the ratio between CO2 and CO is okay, because we are comparing ratios. And then I think it's a good, because until now, if we took periods from this difference will be for short, only for this year. That is not a normal year. Even this winter is not so. It's from the meteorological point of view. This winter was different, was warmer, and then maybe we have to look also to the other years, to the previous data. John Miller is asking which isotopic data are you collecting?
Yeah, you are collecting C13, C12 ratio or delta values for CO2 and CH4. We don't have equipment to oxygen isotopes, but to have our PICAR equipment measure carbon isotopes of the CH2 and CH4 gases.
Yeah, but not yet. It's only for a short period of time. It was Carlos considered not safe to show the results.
Yeah, we need to now with our international standards with traceable to V scales, isotopic scales, we can present these results, these values traceable to international isotopic scale as well.
Yes. Okay. Questions? Also, I think it's better that Eduardo, we are talking here about the satellite data, the availability of the satellite data. That would be nice to have, no? To
Well, I have about one PhD student involved with that, and then we have many different, satellites. GoSat, which is the oldest one, that has both CO2 and methane, but and then you have Tropomi in CO2. But I mean, Isabel managed to get the data from Tropomi and GoSat. Not fairly easily, but she managed. Also, do you have, because sometimes you could use Giovanni just to have like a quick view, but how to download the data? Do you have any special application or something that you have to do, or? Well,
I think they are. Maybe. Do you have an idea?
Charles Miller, do you have an idea on that? Maybe.
I'm sorry, I was reading the chat from John Miller. Could you repeat the question, please?
Yeah. How to basically how to get CO2 data. Sometimes we use Giovanni, but Giovanni, it just can make like quick view. But I don't know if the CO2 is available at Giovanni at least. But is there any special application that you may have to make to get that data or something?
No, the OCO2 data are freely available, and I believe that Sao Paulo has been included in the OCO3 data under the special target mode acquisitions that are being made at the space station. So there should be regular maps being made of Sao Paulo. Let me contact Ryan Pavlik on the OCO3 team to ask him for that, but there might be some imagery that I can get and be able to share tomorrow if you're interested.
Oh yeah, that would be great. Thank you.
No, that would be really nice, no? Yeah, because it will be very useful to have this data and to use this also for the data from Diogo, for the Diogo, sorry, for the F tier. Thank you. Okay. Well, we have many questions, and but I think we are going to. Well, we are trying to solve these problems. A lot of technical problems and a lot of questions about the instrumentation and the calibration. That's not so easy. It seems that it is when we show the results here, but it is a hard job to take the data because sometimes it's we don't have online access to the data. We have to go to the sites, and now for some stations we are going to have the data online, but to do this automatic calibration is not so simple. Sometimes it stops, and we have many difficulties that we are trying to learn how to solve. And this is one thing that I'm saying, because we are having a lot of help from people when we are asking for questions. Like I think people from Picarro, and also from Air Networks, no? And then I took this opportunity to thank people that helps solving the problems, even with this distance, because for us it's quite complicated to I don't know if you notice that, but we take a long time to have all the equipments here, and also the standards. We start importing the standards, but it has to have an agreement between our university and Ynoue, and then after that we were approved to, and then we have first to pay. And this year was quite difficult because people are not working in the university. We have hours to go to do this. Talking by telephone, or this is not so simple to solve the problems, but I think we have a very good results until now. And it's one thing that I'd like to thank all the people that are involved and are making the best to have all this information now working. We even with this difficulty to go to the places and and don't have any support, or almost no support from technical people from the university. That was always a good help, but now it's limited also. And then this year was quite difficult, but I think we made a lot of progress. I don't know if you want to complement, but
yeah, just like to mention that it's good that people that are attending today, you could visit the site that was developed mainly by Carlos and Marcia. Marcia and Carlos made the site, and putting the data and everything together is a very hard work. And if people visit the site, it's good because you can send comments, suggestions, things that you'd like to see. That's always good to have feedback from all of you, because you can improve something. So anyway, and thank you for attending today, participating.
Yes, and in the site also we can have the data, and then it's possible to see what Carlos and Marcia are presenting there. You can have this, you can see the period during the lockdown and after and before. All the data is available there, and then you can see this. This is quite important for us, because then you can have this feedback about the website, that we're trying to keep it with all the information, and also these presentations will be there also for everybody. Okay, some questions, more questions, or some comments? Okay. Well, we can think a little bit more. Tomorrow we are going to have this data, some presentation related to data for particles and emissions factors, and also we are going to have what we have until now related to the modeling, to the atmospheric transport models and emissions. And then I hope you can join us tomorrow, and then please, if you can, have a look on the website, and then tomorrow we can also make comments and suggestions. Okay? Thank you very much for the attention. Thank you for the collaboration. Okay. Okay. Thank you.
Thank you, everybody.
Okay. See you tomorrow then. Thank you very much for being here. Okay. It was so short, but I think it was very interesting. It was a very good conversation. Thank you.
So, Charles, are you still there? Okay.
Ok. Eu acho Ai,
Foi.
que todos ok.
O tempo foi bom, né? Fomos ingleses.
Acho que sim, acho que até poderia ser um pouco mais longo, eventualmente, não sei.
Nossa, o Carlos terminou travado em 12h20.
Nossa, se tivesse treinado não teria dado certo.
Por favor, Richard, muito obrigada.
Tchau para todo mundo.
Tchau, tchau, obrigada, viu?
Obrigada a vocês, tchau.